Good morning, everybody. I'm going to shoot through this presentation as quickly as I possibly can. And at the end, I'll show you what the Google form looks like that you need to finish at the end of this. Gas laws. You guys should know a little bit about this now that you've been working on your gizmo a little bit. There are three variables that are involved with gas laws: temperature, volume, and pressure. Temperature, guys, the higher the temperature of something, the more motion that is in the particles. The lower temperature of something, the less motion that there is in the particles. You guys can think about this as solids, liquids, and gases in terms of water. All right, if we want to make water turn into a solid, I lower the temperature, I lower the energy around it. Therefore, the particles can't move as much, and that water will turn into ice. If I want to increase the temperature, I'm going to increase the energy around the ice. The bonds between those particles will break, and they will turn into a liquid. And then if I add enough energy and enough temperature, I can change it into a gas. Therefore, the particles will move even faster. Volume, we measure the volume of the classroom, and we also measure volume of liquids in graduated cylinders. And a very Googleable definition of pressure is the measure of force applied over a unit area. I'm going to take those three different variables and apply them to two different laws. The very first one is Boyle's law. Boyle's law states that if pressure is increased, then volume decreases. Then if pressure is decreased, then volume increases. Temperature is constant. So you'll notice in those first three bullet points that three variables were used. The three variables I just talked about before: pressure, volume, and temperature. Pressure and volume in Boyle's law, guys, is inversely related. And what it means to be inversely related, it means that if one goes up, the other goes down. If one goes down, the other goes up. So remember, Boyle's law, inversely related. I also used this video here done by the Sci guys. They do a fantastic job. They're a little corny, but they do a really good job in their videos. And I'm going to show you a quick little part of it to give you a little bit better idea of what Boyle's law is.
Temperature, and in a closed system, then its pressure and volume are inversely proportional. What this means is when pressure increases, volume decreases, and as pressure decreases, volume increases. An ideal gas is a theoretical gas.
So you're going to have to use this video or use the screenshot provided to you to try to answer a question on Google Forms about that. So if you need help with that, obviously just go onto YouTube, Google Sci Guys, and watch the Boyle's law video of that. Charles' law: if temperatures increase, the volume increases. If temperatures decrease, the volume decreases, and pressure remains constant. Remember, there's the three variables again: temperature, volume, pressure. Each one of these laws has all three of them. Don't forget about the third one, which is always going to be your constant one, the one that's not being affected. Temperature and volume, unlike in Boyle's law, are directly related. That means if one goes up, the other goes up. If one goes down, the other goes down. Once again, short little clip of a video.
Today on Sci Guys, Charles' law.
Next step in our experiment is to pour boiling water into our glass beaker. Place your balloon into the beaker. In our first attempt at this experiment, we used a water balloon in boiling water. As the water balloon sits on top of the boiling water, it gradually increases in size. There's only one problem with a water balloon: they tend to pop because of their small size. In our second attempt.
So that portion of the video right there, guys, is going to be a question on your Google form as well. So you're going to have to go back and double check that. Once again, if you're not sure of something from this, make sure that you guys are going back to YouTube in order to check that out. So I'm going to leave you guys with this question here, which is an interesting question. I think it's really simple, but I found over the years that there's a lot of people that don't know the answer to this question. So when I blow up a balloon and I tie it off, if I were to hold the balloon up and drop it, will it float or will it fall? Interesting question, because I think most of you will probably know this, but and I don't want to give it away yet. Think about what you think the answer is. Say what you think the answer is. The balloon's going to fall. So if you said that it's going to float, unfortunately, you're incorrect, and you've probably only seen balloons float before, and that's because it has a particular gas inside of that balloon. Think for a second what you think that gas might be. And that gas would be helium, and that's because it's less dense than air. So that's your presentation on gas laws. These are going to be your questions that you're going to be answering on Google Forms. So you should be shooting over to Google Classroom in a second just to check this out. But just to show you what some of those questions are, you can toggle back and forth from the Google Form to the Google Slides that I provided to you. You could also go to YouTube and watch the videos to try to help yourself out with it. So please make sure that you are using all possible resources to get the best possible grade on this. This is kind of my attendance for the day, and also just a quick score to put into the grade book as well. So hope that your virtual school is going okay. Hopefully we get to see each other sooner than later. All right, I'll be talking to you guys again soon this week. Have a good one.